Man, it's been a rough couple of weeks. So about 2 weeks ago, I was moving some stuff around in the shed, brake parts for this thing actually, and I lifted just wrong and threw my back out, which is like normal to me. I've had a bad back since I was a teenager, so once a year, once every other year, it'll go out for a couple of days, and just something you live with. But I was getting all back to normal, ready to rock and roll, and I threw it out hardcore last week, so I haven't been able to do anything in the shop. And so I threw it out. I wish I had like a manly or heroic story about how, I threw my back out, but I was clipping my dog's nails. And I turned and went to stand, and that was it. So I'm finally back to where I'm a little bit better than just gimping around, and I'm back on the charger. I got the front end parts for it, but we're not going to touch that. I can't do any bull work for at least another 2-3 days. So we'll leave that sit. And I've got tons of other stuff to do on the car, including a fuel starvation issue. Now, ironically enough, this morning before I came to the shop, I noticed that DD Speed Shop dropped a video. They're getting their 55 wagon ready for Power Tour. And Danny's boyfriend has done all sorts of, he's got this set up with 2 throttle bodies, a whole sniper thing with wires and lines and all kinds of craziness that goes from one end of the car to the other. Like, this is like next level, like SpaceX technology that they're hitting the road with. And we're supposed to hook up with them, someplace around here, and then roll for a couple of days together. So, just, because I care about my friends, we'll have that ready for them. So, fuel starvation. So fuel starvation is an issue I've had with that car for a while now. The first year or two that we had it together, it was fine. And then it sat for a year or two. And after that, from that point forward, always had a problem with it running out of fuel. About towards the top of second year, it would run out of fuel. I checked, double-checked, triple-checked everything. Could never come up with an answer for it. Until now, I found it, and it's freaky. And I'll show it to you at the end of the video. But on a carbureted car, on a standard carbureted car, the troubleshooting, the diagnosis, the cures for fuel starvation are very simple, very straightforward. Unlike that thing that Danielle's boyfriend is working on, which, it has the same level of technical complication as like a super collider. You know what I mean? It's hopeless to ever try to fix that thing on the side of the road, whereas most of these things can be nursed along on the side of the road. So what I want to do is I want to do a rundown on fuel starvation, the causes and the diagnosing of it, the causes and the cures. And I want to keep this limited to cars, classic era cars, 1950s, 60s, 70s American cars. And I want to keep it limited to working with basically the stock factory components. So in other words, no race cars. We're not talking about a sumped tank or a fuel cell or a high pressure, high volume, fuel pump and all that. No, we're talking about just the stuff that these cars were born with and working with it. And you'd be surprised what you can get out of the stock systems. So the systems used in those cars from all of the manufacturers of that era were universal. There are slight differences. There's a little quirk and idiosyncrasy here and there, but for the most part, they're all interchangeable. And so, if you can fix one, diagnose one, you can fix and diagnose all of them. So, let's start at the very back of the car and work our way forward through the fuel system. All the different things that would cause a fuel starvation issue. But first, troubleshooting a fuel problem. So, the way you tell the difference between an ignition problem and a fuel problem, you're going down the road, okay, and the car starts acting up. Now, if it's an ignition system, if it's an ignition problem, the symptoms are going to be very sharp and abrupt, kind of like a light switch going on and off. So the car will shudder, it'll buck, it may miss backfire, it'll do all sorts of things, but it'll do them in a very abrupt sort of way. Where a fuel problem, a fuel supply problem, will manifest itself slowly. So you'll be driving down the road, you go to accelerate, or you're going up a hill, and the car will just start to hold back. You've given it foot, and it just won't take any more gas. You pull your foot back off the gas, and eventually it'll catch on and it'll go. And it's just telling you that the system isn't supplying the carburetor with enough fuel to meet the demand of the open throttle. So as you close the throttle, the demand meets the supply, and the car will smooth out. So Ignition problems, sharp, abrupt, bup, 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 right? And fuel problems, like that. All right, so we start at the back of the car. And like I said, this stuff is like fairly universal. The first place you want to look for an issue like this is the vent, or the gas cap in most cases. Previous to 1971, almost all of these cars used a vented gas cap. So that's that little hole in the center there is the vent. Now, a lot of guys over the years will replace these not knowing it's supposed to be vented, and they'll replace these with a non-vented cap. Or some of these cars and the later cars have the vent built into the fuel tank. So there'll be a separate line for the vent. The purpose of the vent is to let air into the tank as the fuel level diminishes. The pump won't be able to pull past the vacuum created by the air in the tank, and so you'll have a standoff. Does that make any sense? So if you've got a fuel starvation issue that happens only after, let's say, you're driving around you fill up your tank, okay, and you drive it 40, 50, 60 miles, the fuel level drops 5 gallons, 4 or 5 gallons like that, and now suddenly you have a hard time passing or going up hills, check for that. And the easiest way to actually check it is just undo the cap by 1 notch, because they have like 2 notches on them. So just either leave it off for a couple of miles or just leave it on the first notch so that it's not sealing completely. And if that fixes your problem, you're good to go. All right. So now we go inside the car, right? Or inside the tank, I should say. And you've got a few things inside the tank that'll do this. So this is a common pickup. This is for a Chrysler, but they're all essentially the same. And at the end of the pickup here, you've got this thing. This is called a sock. And what this is it's a pre-filter. It's a pre-fuel filter. It's a coarse mesh. So it's not intended to stop all of the really fine particles, but it'll stop rust, the bigger chunks of rust and stuff like that. Now over time, these things will get clogged. And you'll be driving down the road. This will only allow a small amount of fuel to be pulled through the line, and you'll get starvation. You stop, you slow down, you let the car sit, the fuel will seep back into the filter, into the sock, you start it up, you go, and she's fine, and it'll keep doing it over and over again. If you suspect it's a sock, the only way you can remove one of these without pulling this out of the tank would be to blow compressed air in through the fuel line, blow it back towards the sock. If the sock is clogged, it'll pop right off. If the sock isn't clogged and you're not going crazy with the compressed air, you're just kind of feeding it a little compressed air, you probably won't push the sock off. But if you put compressed air to it and then all of a sudden it goes poof and it starts flowing air real easy, you know the sock was clogged. Now, if by some chance you blow the sock off, that was your problem. You're tempted to say, well, the sock is off. I'm good to go now, right? Don't do that, because the same sediment that was in the tank, and all these old tanks have sediment and rust in them, all of the sediment that was in the tank is now going to get pulled through the rest of the fuel system. And odds are it's going to collect someplace in a convenient area in one of the bends of the steel line. Like if you've got a car, especially a car that you just drive, right? It'll just, in other words, like you're not on it, you're not flowing a bunch of fuel, but the fuel just kind of like just limps through the fuel line. That rust and sediment will gather at a low spot or a tight spot in the fuel line that runs front to back on the car, and it'll eventually clog. The other type of fuel starvation you would have that would apply to this would only happen under hard acceleration. And this is what I suspected was wrong with this car. So when this is in the car, right, so this is facing the front of the car, this is the back of the car. When this is positioned in the car, this sock is about 3/4 of an inch or so from the floor of the tank. You don't want it directly on the floor of the tank, because over time there's like water and stuff will accumulate in the bottom of the tank, and you don't want the sock to be picking that up. So you want this just above the floor of the tank, and you want it back. Now on a regular passenger car, these things will be found, this area right here is going to be right about the middle of the tank. front to back. But in a hot rod, you're dealing with a acceleration. If you've only got, let's say, 4 gallons or 5 gallons of gas in the tank, and the car runs hard, accelerates hard, when you hit it, that gas goes and stands up at the back of the tank, and it'll uncover the sock. Fuel starvation. And now what will happen is you'll be accelerating, you hit it hard, it'll accelerate really hard, let's say through first, it'll be good like halfway through second, and it'll just start to nose over. And then after it noses over, it'll come back. And that's a telltale that this thing is becoming uncovered by acceleration. Because you accelerate hard, the gas stands up at the back of the tank, now the acceleration falls off, the gas all comes back, covers the sock, and she picks up and goes again. So what I was going to do with this, and I probably still will do it, even though this turned out to be not the problem, what I'm going to do with this is extend it about 5 or 6 inches out. I got a compression fitting. I'm going to add a piece of tubing here and extend this out so that it's biased towards the back of the tank, and I don't have to worry about that acceleration doing its thing. All right, so that's the back of the car. That's the tank, the pickup, and now the fuel lines. So one of the most common fuel starvation issues you'll come across, and this is like really universal, is that all of the cars of this era had a pickup that was similar to this, and it had a nipple coming out for the fuel supply, and then there would be the rest of the metal line that would run its way through the car. Well, connecting this to the metal line in the car is always going to be a rubber connector, a rubber hose. Over time, that rubber will dry rot, and when it dry rots, it'll open up enough, just enough, so that the fuel pump is trying to pull fuel from the tank. It'll pull air from the cracks in the dry rotted hose instead. Fuel starvation, 100%. And a lot of times that'll manifest itself where the car is cold, it'll be fine, and then after it sits, you run around for a little bit, it sits, you go to restart it, you crank it, and it'll crank and crank and crank, and no fuel will come up. That's almost always a telltale that you're sucking air through this line here. And this, by the way, is where I found the problem on this car, but we'll get to that in a minute. So working our way forward through the car, we talked about potentially clogged fuel lines as they, the steel line as it runs through the car. Chryslers are especially susceptible to that. Chrysler products used a 5/16 fuel line, a main fuel line that ran front to back on the car, and that was in all of the A, B, C, D, E-body cars. They all used a 5/16 line. The only exception is the Hemi cars. They used the 3/8 line, and the later 446 PET cars. But all of these are stuck with a 5/16 lines, where GM cars, Fords, they used 3/8. Much better system. But still, this will still get you into the bottom 12s or high 11s if it's all totally, if it's all up to snuff. So clogged fuel lines or an air leak in the fuel line, in a metal fuel line, will give you fuel starvation issues. And that's just a matter of going front to back and making sure that it's all copacetic. Blowing air through it, you take the line off at the tank, take the line off at the pump, blow compressed air through it. There shouldn't be any resistance at all. When you blow air through it, nothing should come out the other side except clean, pure gas. If you get a slug of rust or a slug of sludge go through there, replace the lines, because if it started to rust before, the rust never sleeps. It'll just keep rusting and you'll have the problem over and over again. Now we get to the fuel pump, the mechanical fuel pump. Remember, when I was talking about race cars here, we're talking about stock-based systems. So your mechanical fuel pump could fail with just the pump itself being bad. The internal bypass could be bad. The diaphragm could be bad. I've had them where the bowl, the diaphragm in the pump will fill with sediment, which is another reason why if you do take the sock off and it's a car that you use regularly, you want to put another sock right back on it, because whatever small stuff gets pulled through the line and into the fuel pump, it'll clog the pump. I forgot something. We were talking about the rubber line here, this rubber hose, the connecting hose. Well, this being dry rotted will give you that problem, but you can also have that same situation at the front of the car where the main fuel line meets the pump. There'll always be a length of rubber hose there, as a connector, and that can also dry rot. But that has a telltale in that there'll always be a small puddle of gas under the fuel pump, right next to the fuel pump, under the fuel pump. So that can happen at either end of the car. All right, so the fuel pump can fail on its own, but also the fuel pump drive on certain engines, like for instance the big block Chrysler is a perfect example. Fuel pump drive failures are common because that uses a push rod. Inside the engine it uses a push rod that's operated off of a camshaft lobe at the very front of the cam, and then that push rod actuates the pump. And the push rod will go bad. I've seen it where the cam lobe goes bad because it's not lubricated quite as well as the other cam lobes in the engine. So that's always suspect. But yeah, you want to check and make sure that you've got full movement on the pump. All right, going forward from the pump, you've got the filter. And you know, it's either clogged or it's not. So if you're suspecting a fuel starvation issue, it's probably the first thing to check. You know, just pop it off, blow through either side. If it's free, you're good to go. If there's any resistance at all, that's it, she's done. If you're dealing with a clear filter, guys who are new to the stuff, if you're dealing with one of them see-through filters and you don't see the filter completely filled with gas, you only see a little gas at the bottom, a lot of people will assume that there's a problem there or that the filter is clogged. But no, that's actually, it's kind of a normal characteristic. They don't always fill with fuel. Sometimes you'll see just a little fuel at the bottom, but it's still flowing everything that's supposed to flow. I don't know why it does that, but they do. So the last place where you're going to find possible fuel starvation issues is in the carburetor itself, and it would have to do with the floats and the float bowls. So I guess it was probably 30 years ago, I ran into the freakiest fuel supply problem, freakiest carburetor problem I think I've ever had, and it was a General Motors car. And through one device or another, one way or another, you remember the charcoal canisters they used for the evaporation, crankcase evaporation or vapor evaporation? The charcoal that was inside the canister migrated its way into the carburetor and filled the float bowl. So this thing, it ran fine. It ran perfect. Drove down the road great, but you couldn't go more than like 40 miles an hour with this thing. You'd give it gas and it would just go, it would just die. Because the float bowls had filled with this charcoal displacing the gas. So there wasn't enough gas and the floats didn't drop down enough to replenish the gas. So you follow me? And stuff like that happens. It's not, it's rare, but you can find the float filled with different things, you know, depending on how they all get in there and how well the filtration system is for the rest of the engine. But the only thing that could give you a fuel starvation issue inside the carburetor would be something that interferes with the floats being able to go all the way down and then come all the way back up. So a bad adjustment, like for instance on a Holley carburetor, very common. If you over adjust the float bowls, you know, they don't come up high enough, you'll run into a fuel starvation problem because the bowl is not getting enough fuel into it. The float is not coming up high enough to give you the volume that you need to run the engine. All right, so I think I just went A to Z on everything that could possibly give you a fuel starvation issue in a typical classic era American type of car. Let's talk about this one, right? So on this car, when I got it, the tank was dead, right? It needed a tank. So I put an aftermarket tank and an aftermarket unit in there. And I used the hose that was supplied with the unit to make the connections. That's this hose right here. So, like I said, I had a fuel starvation problem with this car after it sat for a little while. It sat for a year or two. And what I found here is that, and this is the first for me, if you look, the rubber hose constricted. This is a 5/16 line right here. And the hose is constricted down in this area to just about 1/4 of an inch, maybe a little bit more than 1/4. But if you follow this hose any further out, it actually constricted even more. So we went from a 5/16 inside diameter to, because this hose did its thing, squeezed down like that, less than 1/4 inch. So I'm feeding a 440 cubic inch engine to an 800 CFM carburetor, attempting to go 5,500, 6,000 RPM through less than 1/4 inch opening for the fuel line. That's what a problem is. The rubber is absolutely petrified. It's like a rock. I took the clamps off of it, put a pair of pliers on it to try to get them off. Wouldn't budge on either side. I actually had to take a Sawzall blade and cut it in half to get it off. And there you go. A constricted piece of fuel line. I've never seen that before. I'm looking at it now, and it actually is legit fuel line. You can see it's got the cloth, you know, the cloth inside. So I have no idea what circumstance led to that, but that's a first for me. So I'm just going to go ahead. Obviously, I'll replace the hose, and I'm going to go ahead and extend this thing a little bit so that down the road, I know I won't have any problems with the starvation. And I think that's it, right? That's the whole, that's the fuel system, front to back. I know anytime I do one of these videos, as soon as I'm done doing it, I remember something that I should have said, but I'm done. Okay. All right, guys. I hope you got something out of that, and I'll see you tomorrow.